My project was the design and development of a 3D printed injector for a rocket engine.
We are doing a project about a floating turbine where we have scaled the tower and the blades and the nacelle and the foundation.
The task was to create real-life prototypes with different functionalities. And what they did is they used the BigRep for creating a casing for this gear.
Last semester we had a semester project about a bicycle frame, because a bicycle frame is also a load-carrying structure, and a bicycle frame can actually fit into a BigRep machine.
This is a mould which is going to form a carbon fibre door for the driver, and so designed a new door for it, and this is the mould again printed on the BigRep.
Normally you have to create a design, test it, and then improve upon it, go back, machine it further. With traditional machining this can be quite difficult, whereas with the 3D printer it's very easy to create multiple versions, print them off, get them tested, and the turnaround is very quick, so it was definitely a benefit.
We 3D printed the frame in one piece. We had the BigRep machine for more than 1 year, and we are very glad to have it, because it makes a lot of things more easy prototyping, fast prototyping.
Now we've got the 3D printer, the BigRep, take a design from the student, and then we just punch it into the printer and print it in one large print, and then go straight into the wind tunnel.
People are really amazed by the things they can do with the BigRep, because now they have the possibility to create prototypes without scaling them down. So they can do prototypes in real life, which is an amazing opportunity for them.